I'm Nick Furness. I'm product manager for the iOS and macOS Runtime SDKs. With me is Mark Dostal. He's a developer on those two SDKs. And over the next 45 minutes, we're going to talk to you about building applications using those SDKs, targeting both iOS and macOS. Now, fair warning, we're going to focus mostly on iOS, but everything we talk to you about will apply to macOS as well. And if you have particular need of macOS, come and talk to me afterwards so that we can understand that and maybe we can shape things up a little better next time. So we're going to cover very briefly some tools and resources that are available to you to get started working with the SDKs. I'll take about 10 minutes over that, and after that we'll dive into code with Mark and we'll show some core workflows. We'll talk about working with the map and the map view, getting GPS location out of your device, and working with remote tasks and services like geocoding, routing, and so on. And in touching on these key workflows, we're going to bump into a bunch of other things as well that we hope you'll find useful when you're building applications using Xcode. So let's get started and look at what you actually need. You'll have to have a Mac, and you'll install Xcode 9 on it. Now, there are ways to do development without a Mac. I don't recommend you really try that too hard. It gets painful very quickly. But a Mac with Xcode 9 on it, an Apple developer account, you can start off free. A free account from Apple now allows you to even build and compile applications and run them on your test devices locally. Previously, you used to have to pay Apple $100 a year to be able to just get the code running on the device. Now you can do that for nothing. When it comes time to deploying your apps to the App Store, then you have to go up to their $99 a year plan. They have an enterprise plan as well that allows you to deploy apps to your colleagues without going through the App Store. That costs a little bit more, I think about $300 off the top of my head, I'm not sure. But their developer pages will tell you all about that. You'll also need an Esri developer account. If you've got an ArcGIS Online organization account, you can use that, log in at the developer site with that. But a developer account is free to create. It gives you access to all the tooling and resources that we have, the SDKs and APIs. When you're building applications with the runtime, you can target iOS 10 or iOS 11. macOS Sierra or High Sierra, that's 10.12 or 10.13. You can write your applications in Swift and or Objective-C. Apple make it really easy for you not to care which one you use. My preference is Swift. I think it's a great language. I think Apple have done a tremendous job introducing that. If you're, just in case you're worried that iOS 10 and iOS 11 doesn't go back far enough, honestly, as of January this year, these figures are taken from Apple. This is their install base in the chart down here. So over 90% of iOS devices in the wild are using at least iOS 10 at the moment. They have a tremendous upgrade rate, thanks largely in part to the fact that they do the upgrades directly. They don't have to go through phone providers or anything like that. So to get started with the SDK, first thing you've got to do is download it. You can either install a package that you download from the developer's site. That includes, that'll install frameworks on your device that you can link to from your Xcode project and start building ArcGIS runtime applications in Xcode. Or you can use CocoaPods. So CocoaPods is a very well-established and popular package managing tool for iOS and macOS developers. We support that. If you have a need for other package managers, there are a few up-and-coming ones in the iOS and macOS developer world. Let me know. We're constantly assessing this, and let me know. We can work on prioritizing support for those if you have a need for them. So with that, I'll jump into the developer's site. Let me get out of the presentation here, and I'll start driving a browser. All right. Everybody see that okay? All right, so this is your home page for this week. Everything you're going to be learning about this week is covered here on the developer's site. It should be your home page as an ArcGIS developer anyway. Down here, you'll see the SDKs and APIs we have. Let's just jump right into the iOS one. So the first thing I want to show you are these tabs up here. We've got the home, guide, API reference, sample code, the community tab that throws you out to the forum over at community.esri.com. And above it, download and install buttons. So this is what I was talking about, downloading and install a package. Download that, run it, and then jump into the install the SDK page, which actually takes us right into the beginning of the guide doc. So the guide doc, this installer page talks about how do I actually integrate this with my Xcode project, what build settings do I need to set in my Xcode project, so on and so forth. Get you started with working with it. I want to just cover a couple of other sections here in the contents. This fundamentals section that covers a lot of key components and concepts that we talk about repeatedly in the runtime, stuff like tasks and jobs, loadable resources, and we'll talk about some of these in the next 40 minutes or so. I also want to highlight these last two sections here, the reference and the release your app section. So the reference includes system requirements and so on. I covered that briefly, there's more detail there. But this release your app section is important, the license your app in particular. When we take a look at this, further down this page we can see the code that's required to actually provide a license key to your runtime applications. Without that license key or without a named user login, you're going to get this watermark at the bottom here, this licensed for developer use only watermark. Now, when you're developing and testing, that's great. It means you have access to all the functionality in the runtime, regardless of license level that that functionality actually requires when you deploy your apps. But to deploy your apps, you need to provide a license, and that's done in a couple of ways. You can either provide a license key to the runtime, or you can log in as a level 1 or level 2 named user and get license capabilities that way. So I'll just talk very briefly about the levels of license. We've pretty much 3 that apply to iOS and macOS developers, light, basic, and standard. And for most people, honestly, light and basic are going to be enough. Light itself is actually pretty all-encompassing. You can do online or offline geocoding, routing, displaying maps, navigating through maps. So you can take a map offline using the free light level and work with it. And if you've got a geocoder or a network model that you can export from Pro, you can use those offline at the light level for free. You can also even edit public feature services. So if you've got public-facing, fully public feature services, you can actually edit those at the light level as well. At the basic level gets more into editing, so authenticated services. If you've got private services that are not public, then you need to go to the basic level if you want to edit them. Again, online, offline, plus all the capabilities of light, of course. And lastly, the ability to add and modify content on your portal. So if you want, you can use the runtime to create a map and then save that map to the portal as a web map for other people to consume. So if you want to modify portal content, you need the basic level. Standard just takes us offline a little bit more strongly, and so if you've got shape files and geo packages that you want to access offline, then you need to go to the standard level. Right now, to enable standard level, you have to buy a deployment package for it from us, but we're working on turning that into a named model as well that's going to be administered through ArcGIS Online. I'll jump into the API reference next. So this is where you get into the weeds. Let's just take a look for a symbol class here. And show you how the reference documentation works. So we've got method and property references here, but we've also got class hierarchies here, so we can jump from the symbol to the marker symbol and see, okay, actually there's 3 specializations of marker symbol. We've already got more properties here that are common to all marker symbols. In the picture marker symbol, we could actually open up a PNG or a JPEG or something and use that as a marker on the map for point locations. On the left-hand side here, you've got all the classes available, and you can dig really deep into the documentation here. That's okay, that helps you understand what all of these classes, how all of these classes expose themselves to you, what properties are available to them. But this sample code tab is going to be really important in understanding actually how to use those. So we've got about 80 or 90 samples now for iOS, and each sample focuses on a specific bit of functionality. So let's, for example, take a look here at displaying a scene. What's it going to take to display a scene? We've got a little bit of documentation here that shows you what you're going to be looking at and what to expect from the sample. We can go over and look at this in GitHub and jump right into the code and see here the code that's required to display a scene. So very straightforward, very simple, but a very focused sample. Now, this sample is part of a bigger app. That app is entirely open source and available for you to download. So you could take the Runtime SDK, install that, download this repo, build it in Xcode, and go and start running. So you've already got an application to work with and explore. It's also available to download from the App Store. And these sample apps are available for all flavors of the SDK. So I've actually got the macOS one running over here. You can see a whole set of samples on the left here. let's just jump into one of them here, this viewshed location one. So here we're looking at on-device. This isn't hitting a service. This is just local viewshed analysis being done against this 3D scene model on the device. That's available on iOS. It's available on Mac across the runtime as of the December release. But if you want to understand how to build this, right here in the sample viewer is the source code. It's going to be really small for you to see there. And also some description on how that was built. So these sample apps are going to be really useful to you in understanding how to take that reference documentation and actually turn it into some functioning code. I just want to jump back to the developer's site really quickly and show you just a couple more areas that are going to be useful to you getting started. And they're even labeled Get Started. So this link here will take us into a page that has actually a good collection of resources for you, covering some core concepts of the platform and the SDKs. But in addition, introducing you to dev labs and the example apps. So the dev labs are 5 to 15-minute exercises, really no more than about 10 or 12 steps. And they're designed to guide you through hands-on learning a little bit of functionality, a new concept of the platform, a new concept of the SDK. So let's jump into here, and we can focus in on the iOS ones, for example, and take a look at this load an item from an ArcGIS portal. You can see it's really straightforward. None of them require that you've done anything beforehand. We'll provide you a starting package, but actually that starting package is itself another dev lab, so you could have built that yourself. And here we understand how to expand that starting package and add a layer directly from a portal item. So these dev labs are very useful to you. People love them. They're really straightforward. We're building more and more all the time. Just very briefly again, I want to go back and just highlight the example apps. I'll talk about them a little bit more in the slides later. But those are more fully rounded applications, not just a single focused sample on a little bit of functionality, but how you might actually use that in the real world. So let's get on to some core workflows here. Just briefly before I hand over to Mark, I just want to cover one workflow, one core concept that I think is a good introductory one, and that is of how we've split up the map and the map view into this model view approach. So a map is very simple. It's just a base map with your operational layers on top of it. That maps directly to a web map that you might create in ArcGIS Online. You can create those in the runtime. You can pull in a web map from ArcGIS Online or from your own portal, and that becomes a map. The scene is very similar, except that it also includes a surface, an elevation model. And you represent a map in your application using the map view. The map view handles interaction. It handles displaying the map, users interaction with it. Likewise, a scene view for a scene. So those two work together hand in hand. And I'll hand over now to Mark to show you how to start putting those components into your own applications. We'll start with a simple application from Mark.
Is that better? Cool. Using a graphics, in a graphics overlay. So we want to go back to our storyboard so we can add a search bar. We're going to drop that on top of the map view. We want to set up some constraints so that it pops up to the top. And then in order to be notified, we need to implement the UI search bar delegate. And that way our application, our code, can be notified when the user types and clicks the search button. We also need to set the delegate for the search bar so that we know, so that the search bar knows it's our code that's going to be notified. And that's simply dragging and dropping this outlet onto our view controller. Now, in order to do the geocoding, we're going to need a locator task. And so I'm going to drag and drop our locator task in. So it's an ArcGIS locator task object, and we're passing in the REST endpoint for the World Geocode server. In order to display the results of the geocode, we're going to use a graphics overlay. And then what we want to do is add that graphics overlay to the map. If I can type, there we go. And we have the geocode results. So we've added that to the map. So anything we put in our graphics overlay will get displayed on the map. And now we've added the search bar delegate, but we want to add a method that will get called when the user clicks search. So using code completion, we can look for the search bar button clicked method. Double click on that, and we're going to copy and paste in the guts of that. So the first thing we're going to do is make sure we don't have an error. And you can see with the locator.geocode method, we get a results and an error. And this pattern is going to be present in most of the tasks, like routing, geocoding, etc. So you're going to get a results and then potentially an error. One of the other things I want to show you is code completion again. So you can see all of the different geocode methods that we have on the locator. And so you can choose the one that best fits, what workflow you want. So we're going to use the simple geocode with the search text that we've grabbed from the search bar up here. First thing we're going to do is check for an error. And we're going to get the first result of the geocode operation. And we're going to see if there's an extent associated with that. If there is, we're going to create a viewpoint and then set the viewpoint on the map view. And what that will do is zoom the map view to the result of the geocode. Once we have the result, we're going to remove all the existing results from our geocode results overlay, just to clear out anything that was there. We're going to get the location from the result, which is a geometry. And then we're going to create a symbol that we're going to use to display and symbolize the graphic that we're going to create. It's a marker symbol. It's a triangle, red, with the size. We have an outline using a simple line symbol. And we create the graphic with our location in the symbol and add that to our graphics overlay. We're going to build and run. And you can see we have a search bar. We're still centered on Palm Springs, but now I can type the name of a restaurant, actually, and find it here in Palm Springs. And so it's not, because it's a world geocoder, it's not simply tied to the extent of the map. So I can also type Edinburgh, Scotland, and find that also on the map. And that's a very quick demo of some geocoding and showing a map in your app.
Thanks, Mark. So let's just review what we learned there. We saw using the map and the map view together to put a map, an interactive map, make it visible to your users, working with Xcode, integrating that with the storyboards, and doing some geocoding. We got introduced to viewpoints, just very briefly, but at least now you know what a viewpoint is. They come in handy throughout interacting with the map view. And we saw graphics overlays, graphics, and symbols working together to represent something on that map. So not only did we have a base map, but we started to add some data to it. I want to spend a little time talking about the task pattern that we saw there. Mark mentioned it, working with the geocoder. So this task pattern repeats itself throughout the runtime, where you've got an object, when you're in online mode, typically a remote object like a service somewhere, like the geocoder or a routing task. And how you work with that in the runtime is to create one of these task objects pointing it at that service. You could also point it at a local file. So you could have a geocoder locally on the device, construct your task one way or the other, and from that point on, all you do is you call actions on that task. So in our case, we wanted a geocode. We passed in some parameters, and we got a pair of things back. Possible results, possible error. So the first thing to do is to check whether there was an error. If there was, report that back to the user somehow. Now here we're just writing it to the console log. You'd want to pop up an alert, log it to your own tracking, whatever you need to do to make sure your app is robust and the user knows why it didn't work. And then, if there is no error, then you can go ahead and process the results. And we saw in Mark's case, he went ahead and dropped a pin on the map and zoomed the map to the extent of the result. So with that, I'm going to hand back to Mark now. We're going to carry on adding stuff to this map app and teach you a little more about the runtime.
All right, so using the same application that we just created, we're going to add our own feature layer, because the existing map that I showed you just had a base map. So we're going to add a feature layer so we can display some features, and then we're going to identify those features. So right here, after we created our map, I'm going to create a feature layer. First thing we do is create a service feature table from a REST endpoint. This is your service. And then using that feature table, we're going to create a feature layer. And like Nick said earlier, we have the map operational layers array, and we're just going to add that feature to that array. And that's all it takes to display features on the map. The next thing we want to know is, and provide for, is user interaction with the map. So if the user taps on a feature, we want to be able to identify which feature they tapped on and then display some information for that. So again, we need to implement a new delegate. In this case, it's the GeoView Touch delegate. And that will, once we set the delegate on the map view, let us know when the user taps on the map or interacts with the map in some way. So the map view has a touch delegate property. We're just going to set that to self. So that way the map view knows who to talk to, who to tell when something happens with the map. So the same way in which we implemented this delegate method, we're going to implement the GeoView did tap at screen point delegate method. And you can see these are all the touch delegate method implementations. We provide, that wasn't right. There we go, we'll do that. So we provide for long presses, touch up, taps on the map, end long press, force touch. So essentially all the user interactions that iOS supports, we support on the map view. So when the user taps at the map, we get the GeoView, we get the screen point where they tapped, and we get a map point. So what we want to do is identify at that screen point. So we're using the identify layer method on the map view. But you can see we provide many different kinds of identify based on your use case. There's some that takes just a layer, some that identifies all layers, graphics overlays, all kinds of stuff. So whatever works the best for you, we provide. First thing we want to do, and you can see here again, we get a result and a possible error. In this case, we're going to get the first result. Make sure we have that. And then we're going to get the first feature in the GeoElements array in the result. And we added a feature layer, so we know this is going to be an ArcGIS feature. The map provides a callout, which is a real simple way to display information from features or graphics on the map. And we're going to get the map view callout title and set that to essentially an attribute in the features attribute dictionary. We're going to use the name for the title, and we're going to use a short description for the detail, and then we want to show the callout on the map view, and we're passing in the first feature along with the location that the user tapped at. So we're going to build and run. We're going to see a couple things. We're going to see the same map, but it's going to have our feature layer that we added to the map, and we're going to be able to tap on the map to identify features. So here's our map, centered on Palm Springs, and now you can see we have features on the map. So we can click on one of these features, and we're doing the identify once the user taps on the map, and we're getting the title and a description and displaying that in the callout. So this little I is what we call an accessory button, and we're going to use that in the next bit, so we haven't hooked it up yet. But that's how easy it is to add a feature layer to the map and do an identify based on user interaction.
Good. Good stuff. All right, just a quick review then. We just saw adding your own data, right? So we're starting to build up a map that means a lot more than just the base map underneath it and where you just searched. And we introduced you to some of the patterns involved in actually interacting with that map. So taking your user's intent of working with the map and being able to turn that into some application logic of your own. Before we jump back into the demo, I just want to introduce you to a couple more patterns. We talked about the task pattern. The job pattern and the loadable pattern are also important in the runtime. So where the task pattern is about hitting a remote service, it's going to come back fairly quickly, do some work and come back fairly quickly. The job pattern is about long-running tasks, like doing some big geoprocessing task or taking a map offline, where you fire off a request and then you're going to get something happening over time on the far end, sending back status updates from time to time. And then there's the loadable pattern. So a lot of the things that we're working with are remote services that have metadata about them. So for example, when you create a feature layer reference, you've got an object in Swift that says, I am a feature layer that points at this URL that you just told me to point at. But it's got properties on it like extent, renderers, and so on, that at that point in your code's execution, the runtime hasn't had a chance to go out to the web and come back and load yet and hydrate. So the metadata is not down yet for that object to be usable. That's what we mean by loadable, is there's enough metadata to use that object. So the loadable pattern allows you to wait for that metadata to exist before you continue and use that object. But we also use it internally to hide a lot of complexity and dependencies from you. So if you have multiple things that all have to be loadable and hierarchically depend on one another before you can use them, for example, a map that uses a portal item for its web map that uses a portal that it belongs to. All of those, each of those things is loadable. You don't need to know about that. We hide all that from you. But understand why some properties are not immediately accessible because of this asynchronous nature. And if you want to learn more about all of these patterns, there's a demo theater tomorrow at 1:30 back in the main showcase area, demo theater 3, that covers each of these patterns in a little more detail. So with that, we'll jump back to Mark, and we'll add some final bits to this demo.
So once the user creates a route, taps on a feature, initializes the routing, we're going to need to display that. And again, we're going to use a graphics overlay. And again, we're doing lazy instantiation of this, but we're going to do it a little differently this time. So in the previous example, when we displayed a graphic on the map, we created the graphic with a symbol. This time, we're going to use the graphics overlay and the renderer property on the overlay. I'm creating a simple renderer using this line symbol. The advantage of this is you don't need to create a separate symbol for all the graphics you add to the map. And it's one place where you can change the symbol that will affect everything that gets rendered from that graphics overlay. Now, since we want to display the results from our current location, we're going to need to turn on the location display. And that's a property of the map view. And what this does is it provides all of the CocoaTouch CL location manager code for you in one method. So it's going to start the location manager It's going to start receiving location updates, and this hides all that complexity for you. So one of the things, though, with an application is when you start accessing the GPS, you have to explicitly give your app permission to access that, which will then prompt the user for their permission to start using the GPS. And that's done here in the property list. And I'm going to find it. So what we want to do is provide a location when in use description. So we're just going to, the little message that's going to be displayed is to access your location. So the user knows why you want to access the GPS. So in order to initiate the routing, we're going to use that accessory button on the call out. So we want to implement another delegate protocol, ArcGIS callout delegate. And then just like we did here for the touch delegate, we need to set the callout delegate. And we want to provide a custom accessory button image. So inside your assets here, we're going to just paste in a direction image. And this will get displayed in the callout. And then when the user taps on it, it will initiate the routing. So as we did for the did tap at screen point and the search button click, we need to provide a delegate method that will get called when the user taps on that accessory button. Did tap accessory button. So because we set the delegate, this will get called. All right, so you can see this is a little more involved, so we're going to go through this whole thing. First thing we want to do is dismiss the call out so that it doesn't get in the way of our route. And we're going to use this defer command, which ensures that this bit of code will get executed before this method leaves scope. So that way we can ensure that the callout gets dismissed. Now remember when we showed the callout, we passed in the feature that was tapped on. We can get that back using the callout represented object. So that means we don't have to hang on to the feature in another variable. We can actually get it right from the callout. We're also going to get the location from the geometry of the result. And then we need to get the default parameters from our route task. So this is going to go and hit the service and return all of the default parameters. Again, there's a parameters and a potential error. The thing to note is if this is called more than once, it's not going to refetch it from the network. It's just going to use a cached value. Check for error, make sure we have parameters, and then we're going to use our location display to get the current map location. Again, this uses the CL Location Manager Cocoa Touch code. And it's just essentially 2 lines that we've used for the location display. We called start, and then we get the current location. We want to set a couple of additional parameters, the output spatial reference and the directions units. We want to create 2 stops, a start and an end, start and an end. We're using my location as the start, and we're using the result location, which we got from our feature, as the end. We set those stops on the parameter, and we call solve route on the route task. Again, we get a result and a potential error. Check for errors. We get the first route in our route result, and we get the geometry from the route geometry. Remove all the previous results. We add a graphic to the results graphics array. And we're creating a graphic using the geometry, but we're passing nil for the symbol because remember we set a renderer on the route results, so we don't need to pass a symbol in here. And this for me is the coolest line of code in the whole demo. What we want to do is zoom the map to the result of the route geometry. But we want to expand it a little bit because we don't want it going right to the borders. So we have our route geometry, and that geometry has an extent. All the geometries in the Runtime SDK are non-mutable, which means you can't change them. So we use geometry builders to allow you to create and modify geometries. So with our extent, we convert that to a builder. We create a builder object. And then we call expand on the builder by 1.4. And this expand method returns a builder. So you can use Swift's method chaining to just simply continue on one line. And then with the builder that's now expanded, we call toGeometry to get the route extent. We create a viewpoint, as we've done before with our route extent, and set that on the map view. So if we simply did this, it would automatically zoom the map to that location instantaneously. But we want to provide some cool animation. So what I'm going to do is self.mapView. And you can see we have many different set viewpoint methods. So the one we're going to use has a duration. So we're going to use our same viewpoint that we create here. But we want to give it a duration. So we want the animation to take 2 seconds. So in iOS, one of the really cool things across the whole OS is all the nice animations that happen. And so we're going to do that here. We do not need a completion handler, but the completion handler is something that would be called when the animation finishes. So at that point, if you wanted to provide a different animation or do something else, you could do that. So we're going to get rid of that one, and we're going to build and run. So the first thing it's going to do is ask you if it's okay to use the location. You can see we have the description, the usage description that we put in to access your location. So we're going to allow that, and it's going to display the current location here. You can see our feature layer is still there. What we want to do is click on a feature. We get the call out, and this is the second El Mirasol restaurant. But you can see there's our nice route graphic that we added, the directions graphic. And now I can click on this because I implemented that method in the protocol, the delegate. Dismisses the call out. And I missed something. What did I miss? So I created the overlay, our route results. But what I did not do is add it to the map view. So while I added the graphic to the overlay wasn't added to the map view. So now we should see results. All right, once again, there's our location. We can click on a feature, and we can route with a nice 2-second animation. Then find something else, click on it, and route to that location. Removes the old result, adds the new one, and slowly zooms to that extent.
Yeah, so the question was about third-party high-accuracy location providers, and whether there's any work being done on making it easier to integrate with those. So the integration point I talked about of building your own location display is one approach, and I know we are working on other stuff, and stuff from the collector app is going to. I think there's one project that's going to be made available as an open source extension, so you can take that stuff. But what I would recommend is come to the Showcase Island. I think you want to look for a guy named Eric Ito, and not to drop him in it, but come to the Showcase Island, find me, and I'll help you find Eric. I think he's here today. But otherwise, we can take you over to the Collector app team as well, and they can help you really understand that too. But the answer is there are solutions, but I'm not quite sure. Okay. Yeah, I would. Yeah, let's have that conversation. Anything else?
So basically developing the app and everything, but what we're looking to is like how can we do UI automation?
UI, sorry.
UI automation, so like creating unit UI automation test, so
Okay.
that we have like exposed all of these markers and things that we interact and like
Okay. Well, the question was, do we have any ways to enable UI automation testing, including integrating with the map? And I don't know the answer to that, I'm afraid. Do you have any insight on that?
We do some automated UI testing, but it's mostly displaying a map and then comparing that image to a reference image. So we don't do any, click on a button and do this kind of thing. But you can stop by the island, and we can look into that a little bit. Yeah.
I have a question on y'all showed the route, showing a route on the map. Is there turn by turn included in the API?
Yes.
Yes.
Directly turn by turn?
Yeah, so
Yes.
the question was, in addition to just putting the route on the map that we saw in the demo, you want to?
Yeah, switch to 3.
Can we get turn-by-turn directions out of that? And the answer is yes. I think you may need to add another parameter to that input parameter that says, give me back the turn-by-turn directions. But the World Routing Service returns those. Yeah.
Is that a different license level?
Nope.
Nope.
Can we done under light?
Yep. Now, if you're hitting the World Geocoding Service, it can be done under light, but it does consume credits. Right. Yeah. So it's just standard credits as if you were doing route results in the viewer.
What if you wanted to use your own routing service?
Yep. So if you've got your own routing service, that's easy. You just point the URL and the constructor to that. If you're generating your own routing service, you can even generate an offline package and just do it, sideload that onto the device, point the constructor at that, and do that on the device. So those approaches don't consume any credits. Yep. So the question was dealing with, we showed a call out displayed on a single item, dealing with multiple items in the call out, or dealing with something like a map service. So for dealing with multiple items, that call out is really designed just to display a single piece of information. But we have a whole pop-up model that you can use that can display a whole range of results. So that the pop-up viewer is much more detailed. You can configure the pop-ups in your web map, or it can just go against the pop-up definition on the layer, and it reads those and displays those. For call-outs with multiple results, another approach you could do is you could use a custom view within that call-out. So you can give it a UI view and then handle that along with all we're doing when you do the touch, you do an identifier, and you do actually get a number of results back. We just worked with the first one. You could do a custom view in that call-out that displays whatever you want from the multiple ones, maybe an aggregate of them all, or however you want to page through them. Right? It could just be a table view that shows that. So we give you the flexibility to make that call-out really look like what you want it to. But for a lot of use cases, pop-ups might be more appropriate as well. Anything you wanted to add to that?
No, that's
maybe for the map image server, because we've done some work with that, right, in terms of getting results back from that. So you can query that and get results back.
Yep, if the service supports Identify, it will be returned in the Identify layers method. or the identify layers call. So.
Any more? We've got 5 minutes.
So we have added the code to basically add any layer of the operational layers, right?
Yes.
Whenever we do that part, what's like the recommendation? Should we add all of those code orders in the main thread, or that's taken care by the SDKs?
The SDK takes care of it, so you don't worry about threading. So we make the assumption that you're going to be hitting us from the main thread. That's the major use case, because you're reacting to interaction from the user. Most of the ways that iOS calls in is going to be on the main thread. So when you call us on the main thread, we'll push stuff off onto a separate thread. We'll do all the work in the background, but we'll return to you on the main thread as well. So you're then okay to do UI updates and what have you. If you call us from not the main thread, then we don't guarantee what thread we're going to call you back on. I believe that's correct.
I believe so, yes.
Yeah. But if 99% of cases, people are going to be hitting us from the main thread, so we take care of all that for you.
Yep.
It's good practice to wrap it up.
Yes. Yep. Yeah, because we do, like when you do an identifier or a route, it took a little while, but that's all happening in the background, so the map is still responsive. You can pan and zoom and do whatever you want. And then it's the completion handler gets called back on the main thread. So you can do the work then and then update your UI if you need to.
Well, your last question about whether it's best practice to always call us from the main thread, I don't know that that's necessary. What I would say is that when you handle the result from calling us, you should do that on the main thread, because then you're really if you're dealing with UI, right? You have to do your UI stuff on the main thread, or you don't know what to expect. Going once, going twice. All right, thank you again for coming by. I hope this was useful to you. Let us know in the feedback how we can improve this for next year, and enjoy the rest of the conference. Thanks a lot.
Thank you.